So for this problem, we have log base 2 of x, and then our different values for x are 1/4, 1/2, 1, 4 square root 2, and 32. So we could do this by hand, and we can also use our calculator. So first I'm going to do it, or I'll show you both ways. So you have x as 1/4, and then log base 2 of x. So you're going to take 1/4 and plug it into x. So you have log base 2 of 1/4. Now you don't know what that equals, so let's say it equals a. And then using, we're changing this from logarithmic to exponential form, you get 2 to the a equals 1/4. And then 1/4 is the same thing as 2 to the a equals 1 over 2 squared. 2 squared is 4. And then since it's in the denominator, this becomes 2 to the a equals 2 to the negative 2, right? The denominator makes it become a negative exponent. And so then you get a equals negative 2. So that's going to be our first one, negative 2. Now 1/2. So you have log base 2, 1/4, or now instead of 1/4, 1/2. 1/2. And we don't know what that equals, so you make it equal to a variable like y. And then to change it from logarithmic to exponential form, you get 2 to the y equals 1/2. Now this is 2 to the y equals 2 to the negative 1, right? This is an implied 1 as an exponent. Since it's in the denominator, 2 to the negative 1 is 1/2. And you can even verify that using a calculator. You can see that 2 raised to the negative 1 is going to give you the same thing as 0.5. Right, so that's what the negative exponent does. If the exponent's on the denominator, it moves to the top, it becomes negative. And so then here, your y is negative 1. So the bases are the same, right? 2, base 2, base 2. So y is negative 1. So y equals negative 1. The next one is 1. So then you have log base 2, and then instead of writing x, you write what x is, which is 1. We don't know what it equals, so make it equal to a variable like y. So now you have 2 to the y equals 1. Now, 2 raised to the 0 would be 1, right? Anything raised to the 0 gives you 1. And you see now the bases are the same. Using the equality or 1-to-1 property, you can see that y is 0. So y is 0. Now 4 square root 2. So this is log base 2, and then instead of writing x, you write 4 square root 2, and you don't know what that equals, so you make it equal to a variable like c. And so you get 2 to the c equals 4 square root 2. So you get 2 to the c. Now we want to write this in the same base. 4 is 2 squared. Square root of 2 is 2 raised to the 1/2, right? 1/2, think about changing it from radical notation to fractional or rational exponents, 1/2. And then with these exponents, you actually add them. So the property is like if you have something like this, x squared, x cubed, you add them and that becomes x to the 5th. So you get 2 to the c equals 2, and then 2.5, or you could write 2.5, which is the same thing as 5/2. 5/2 is the same thing as 2.5. And so c equals 5/2. And then 32. So we have log base 2, and then instead of writing x, you write 32. We don't know what it equals, so make it equal to a variable like a. So 2 to the a equals 32. And then I think, let's see, 2 to the 4th would be 16, so I think this is 2 to the 5th. And you can check this in your calculator. 2 to the 5th, does that give you 32? So 2 raised to the 5th does give you 32. So since the bases are the same, you can just look at this. A equals 5. And so we're done. There is a way to do all of this in your calculator. So you have your x's, and you have log base 2x. So you have 1/4, 1/2, 1, 4 square root 2, 32. So you're going to plug in log base 2 of 1/4. Now to plug this into your calculator using change of base, this becomes log of 1/4 divided by log of 2. So calculator, you have log of 1/4 and then divide it by log of 2, and you get -2. And then when you plug in 1/2, you have log 2 1/2. So using the change of base, this becomes log of 1/2 over log of 2. The base goes on the bottom, so log of 1/2 and then divided by log of 2. Again, this is using the change of base formula, so you get -1. And now plug in 1, so you have log base 2 of 1, so this becomes log of 1 over log of 2. In your calculator, you have log of 1 divided by log of 2, and you get 0. And then log base 2 of x, x is 4 square root 2, so this is going to become log of 4 square root 2 divided by log of 2. Your base goes on the bottom. So in the calculator, you'd have log 4 square root of 2 divided by log of 2, and you get 2.5, which is the same thing as 5/2. 2.5 5/2. So you can see we're getting the same answers, -2, -1, 0, 5/2. And now we're going to plug in 32. So you have log base 2 of x, but now x is 32, so this becomes log of 32 divided by log of 2. Now, we could have also done all these in ln, so we'll do this one in ln. It's going to give you the same answer. The change of base says it doesn't matter what base you use, it just has to be the same. So instead of using log, I'll use ln. ln of 32 over ln of 2. So ln of 32 divided by ln of 2, and you get 5. So you can do it by hand or using your scientific calculator.